Alright, so our next activity here is called story time, matching equations. So the instructions. Here are 3 situations, numbers 1, 2, and 3. And we are given 6 different equations, and we only need 3 of them. 3 of them will be used to represent these 3 situations. So that's the cool thing about variables and algebra, is that we can use these equations with a variable to figure out real world problems. So let's look at number 1. So after Elena ran 5 miles on Friday, she had run a total of 20 miles for the week. So she ran X miles before Friday. How many miles did she run before Friday? Okay, so it's important to know X in this situation means the miles she ran before Friday. So it's always important to make like a key that labels what your variable means in that situation. Because you can see in all of these, there's X in all of these, but for each problem, X is going to be representing something different, something else. So in this situation, X is the miles before Friday. And we also know that she ran 20 miles for the week, a total of 20 miles for the week. So her total for the week was 20. Alright, and it's also important to note that 5 was how much she ran on Friday. So once again, we're kind of annotating our text here. So we are paying attention to the important numbers. We're circling the numbers and underlining the labels that go with them. And then down below here, we're creating this key. So X is the miles ran before Friday. 20 was her total. And 5 is the miles she ran on Friday. So now, when picking which equation we're going to use to represent this situation, we need to think about what kind of operation is happening in this problem. Is it addition, subtraction, multiplication, or division? So, this problem, are we taking her miles on Friday and multiplying them? No. So, if we're looking for her total number of miles, this is actually going to be an addition problem. So, it would be the amount of miles she ran before Friday, which is X, and then we add her Friday miles, and that would give us her total of 20. So, this first one is actually going to be the equation that we use. X plus 5 equals 20. If you took her miles before Friday, added them to the ones she did on Friday, that would get you to her 20 total miles for the week. So now let's actually solve this. So if we want to find the miles she ran before Friday, whenever we solve for a variable, as mentioned previously, we can turn this into a sentence replacing X, or the variable, with the word what. So, what plus 5 equals 20. And we can kind of just figure this out in our head, that 15 plus 5 equals 20. If we wanted to solve this algebraically, we always solve using inverse operations, meaning that we do the opposite operation to solve. So if I know something plus 5 is 20, if I subtract 5 from both sides, that will give us our answer. So remember, that's how we always solve for a variable, is by doing inverse operations. So x equals 15, so 15 miles before Friday would be our answer here. All right. Now let's look at the other two. So Andre's school has 20 clubs. So once again, let's annotate our text, which is 5 times as many as his cousin's school. His cousin's school has X clubs. And then our question, how many clubs does his cousin's school have? So that's our question. All right, so once again, let's make our key. So X is his cousin's school's clubs. And then we see the number here, 5. So 5 times as many. We'll say how many times more clubs that Andre's school has. And then 20 is the total amount of clubs at Andre's school. So, once again, it's up to us to determine what operation is happening in this problem. If you read the word problem closely, there's kind of a word that gives it away, actually, and that word is times. We know whenever you hear the word times, instantly you should be thinking about multiplication. Okay? So, if this is a multiplication problem and 20 is the total amount of clubs, that's going to be on its own. And so Andre's school equals 20, X is his cousin's school's clubs, and we need to take the amount of clubs at his cousin's school and multiply them by 5 to get the amount of clubs at Andre's school. So 5 times the amount of clubs at his cousin's school is the 20 clubs Andre's school has. And so, once again, here to refresh, this is an example of next to notation. Remember, next to notation is the idea that when working with variables, if you ever have a number attached to a variable with no operation symbol, that's actually multiplication. Okay, so this is 5x is actually 5 times x. So this is a multiplication problem, and we can refer to that as next to notation. Just a number next to a variable represents multiplication. Also, another thing that we used to talk about is that number in next to notation that's attached to the variable, we call that the coefficient. A little math language for you. Okay, the coefficient. Now, once again, whenever we solve for a variable, we need to use inverse operations. So we could think of this as 5 times what equals 20. 5 times what equals 20. So if this is multiplication, the inverse or opposite of multiplication is division. And I can divide both sides by the coefficient by 5, and I'd get x equals 4. And then this is a word problem, so we always need to have a label at the end. And so the question was, how many clubs does his cousin's school have? And x is this clubs at his cousin's school. So 4 is the number of clubs. At his cousin's school. Always just circle your answer as well. Okay. And now, one more. So, Jada volunteers at the animal shelter. She divided 5 cups of cat food to feed 20 cats. Each cat receives X cups of food. So how many cups does each cat receive? So once again, in a word problem, you can often look for key words in the problem to figure out what operation this is. So right away, we should have recognized that we had the word divided. So this is a division problem. So she divided 5 cups of food. So 5 is actually going to be our total here. Because if we remember, the total in division is always the number that's getting divided. So 5 is what's being divided, those 5 cups. So it's really easy to think 20 is the number that's being divided because it is the larger number, but in division, it's always the number that's getting divided, that's getting split up. That's our total. Okay? So the total is 5. And also, when we think about our division key, we've got the total, we've got the number of groups, and we've got the size of each group. So, these 5 cups are being divided to feed 20 cats. So each cat is going to represent a group, and then what we're trying to find is how much did each cat get. So that is the size of their meal, the size of their food, how many cups they got. So, in division, we have our total divided by the number of groups would equal the size of each group. So 5 divided by 20 equals X. All right? So these 5 cups divided by 20 cats will be the amount that each cat receives. However, we can see that this actually wasn't an option in our equation. So we're going to have to find out how else we could rewrite this based on one of these problems here. Okay? So 5 divided by 20 equals X could also be written as the 20 cats and the number of food they get, the amount of food they get, would also equal the total of 5. So, once again, this is the idea from, if you think back to our first activity, working with tape diagrams, is that when we work with multiplication and division, those are inverse operations. So we can use inverse operations to represent the same situation. So let's solve to make sure that they both work. 5 divided by 20 equals X. I can rewrite 5 divided by 20 as a fraction. And so the GCF here, the greatest common factor, is 5. So 5 over 20 is actually the same thing as just 1/4. So that would mean that each cat received 1/4 cups of food. Okay? And then if I plug that back in, if I substitute in this situation, I should get the same answer. Okay? So 20 times 1/4. So when you multiply by a fraction, the whole number multiplies by the numerator. This would be 20 over 4, and this would be 5. So we could see that in either situation for X, I would get the same number, which is 1/4.